Hi, so I'm Jackson Fike. There's my student ID. The first part, video presentation of the stereochemistry. When I first drew it, this is supposed to be big capital A, just like that technically. But yeah, so I drew or tried to have enough materials to do the other little a, little b, and little c. But I just did the same one, just kept using the same model and rearranging it every time. So with that being said, this is supposed to be capital A, sorry. This is the one I was working on little a, little b, and little c on. And no matter how I turn it or the orientation lies, it's always ending up with the two hydrogen groups like so. So no matter how you hold it, you can always rearrange it to look like this, which has me thinking that they are enantiomers of each other. With that being said, they are also not identical, as you can see. Because if they were identical, then both this would be coming out this way, and the hydrogen group would be going out that way, and then that way you could lay them on top of each other like this, and they would be exactly similar. But since you can't do that, you know that they are superimposable, but they and mirror images of each, or they are non-superimposable, but they are mirror images of each other. So you can't have them identical. They're like a pair of hands. So with that being said, moving on to the polarimetry, I was having a little bit of trouble with this part of it because this is the alanine, and I have it set to where the bottom polarizing sheet is taped to that one, is taped to that top one there. And so when I put this on there, it's kind of hard to determine because I have a circle, whatever this is called, and I put this on here, and it's kind of hard to line up. But no matter where I go, this way or this way, it's always lining up exactly how the one below it is placed. And the other two were very similar as well. So for example, I got no difference on this alanine, and strangely enough, all of these were at the same level. So approximately 10 degrees, the glucose was going, polarizing sheet going this way was 10 degrees, and the fructose was 10 degrees going that way, so 10 degrees negative is what I said on there. Yeah, and how could you know the molecules are optically active just by looking at the structure? Basically just the same way, because you know, because they are not, because you know the structures are coherently different, you know that they can reflect light differently based on these properties that we've learned. And I just showed you how we found the extinction point as well. So I guess I will also include, I didn't do my calculations on what's required for this, so I will also include a picture as well of my calculations with my ID in it, so my apologies.